In the vast silence of space, where distances are measured not in kilometers but in light years and time itself stretches thin, astronomers are used to surprises, but very few discoveries truly shape their understanding of the cosmos. 3I Atlas is one of those rare exceptions. When it was first detected, it appeared unremarkable, just another faint object slipping through the background noise of the universe. But as more data arrived, scientists realized something was deeply unusual. This was not simply another comet or asteroid drifting through our solar system. Its trajectory, speed, and behavior suggested something far more extraordinary. Once again, the universe had delivered a mystery that refused to stay quiet. The designation 3I Atlas itself carries enormous significance. The 3I label confirms it is only the third known interstellar object ever observed passing through our solar system, following the historic discoveries of Oumuamua in 2017 and 2I Borisov in 2019. Each of those objects challenged existing theories, but 3I Atlas pushed those challenges even further. If Oumuamua was a whisper and Borisov a warning, then 3I Atlas arrived like a signal, clear, undeniable, and impossible to ignore. From the moment the Atlas telescope system identified it, scientists noticed its velocity was far too high for a normal solar system object. Anything gravitationally bound to the Sun follows predictable orbital paths, shaped over billions of years. 3I Atlas did not. Its hyperbolic trajectory confirmed that it was not a native resident of our system. It had come from the dark space between stars and would leave just as quickly, never to return. In a single calculation, an ordinary detection became an interstellar event. As telescopes across the world focused on 3I Atlas, more anomalies emerged. Its brightness varied in unexpected ways, suggesting a complex shape or irregular rotation. It displayed activity, but not the kind scientists were accustomed to seeing in classical comets. Dust emissions appeared without the strong gas signatures typically associated with icy bodies. This blurred the line between comet and asteroid, placing 3I Atlas in a category that did not fully exist before it arrived. What makes 3I Atlas extraordinary is not just how it behaves, but what it represents, a physical fragment of another star system. It formed around a distant star, under conditions we can only model, not observe. It survived ejection from its home system, endured millions or even billions of years in interstellar space, and then, by sheer cosmic coincidence, crossed our path. Every photon reflected from its surface carried information from a place humanity has never seen. Time quickly became the enemy. Interstellar objects move fast, and observation windows are short. Within months, 3I Atlas would fade beyond the reach of even the most powerful telescopes. This urgency triggered a global observational effort, combining optical imaging, infrared measurements, and spectral analysis. Yet instead of converging toward simple answers, each new dataset revealed more complexity. Spectroscopic observations produced some of the most puzzling results. The chemical fingerprint of 3I Atlas did not align cleanly with known solar system objects. Certain volatile compounds appeared depleted, while others behaved unpredictably. Dust seemed dominant, while gas emissions were faint or inconsistent. Scientists began to suspect that long exposure to cosmic radiation had altered its surface chemistry, creating a hardened outer layer that concealed its internal composition. Interstellar space is brutally unforgiving. Without a protective atmosphere or magnetic field, objects are bombarded by high-energy particles that can chemically transform surfaces over time. If 3I Atlas spent vast stretches drifting between stars, its outer layers may have been processed into a radiation-resistant shell. This would explain why it appeared active yet restrained, like an object that had already lost its most fragile materials long ago. Comparisons with earlier interstellar visitors were unavoidable. Oumuamua lacked a visible tail but showed mysterious acceleration. Borisov behaved more like a classic comet yet still defied expectations. 3I Atlas seemed to exist between these extremes, reinforcing the idea that interstellar objects are not a single class but a diverse population shaped by origin, age, and history. Tracing its path backward through space offered only partial clues to its origin. While scientists could not identify a specific parent star, models suggest it likely came from a dense stellar environment, where gravitational chaos is common. In young star clusters, Planetary systems frequently eject debris as giant planets migrate and stars pass close to one another. 3I Atlas may be a survivor of such violence, expelled long before Earth formed. Its rotational behavior added further intrigue. Instead of spinning smoothly, 3I Atlas appears to tumble, rotating chaotically through space. This motion implies past disturbances, collisions, asymmetric mass loss, or powerful gravitational interactions. The fact that this tumbling persists suggests a rigid internal structure, capable of preserving rotational chaos over immense timescales. As scientists analyzed the statistics, a deeper realization emerged. Detecting 3 interstellar objects in just a few years implies that the galaxy may be filled with them. Most are simply too small or faint to detect. Our solar system may be constantly visited by material from other stars, passing through unnoticed. 3I Atlas may not be rare at all, only briefly visible. This discovery has forced astronomers to rethink planetary system boundaries. Rather than isolated islands, star systems may function as open environments, exchanging material across the galaxy. Dust, rock, ice, and organic compounds could migrate between stars, carrying chemical information across cosmic distances. In this context, 3I Atlas becomes evidence of galactic connectivity. Looking outward, scientists began to see 3I Atlas as a preview of astronomy's future. New observatories, particularly wide-field survey telescopes, will soon scan the sky continuously, detecting fast-moving objects earlier and in greater numbers. When that era arrives, interstellar visitors will no longer be singular mysteries but part of a growing dataset, allowing patterns to emerge. Those patterns may reveal common origins, shared chemical traits, and recurring physical structures. Each interstellar object will act as a messenger from another planetary system, delivering information without spacecraft, without engines, and without intent, only motion and time. Perhaps the most profound implication lies in chemistry and life. Interstellar objects can carry complex organic molecules formed in cold space or young planetary disks. If such objects routinely pass through star systems, they may deliver these molecules to planets and moons, spreading life's building blocks across the galaxy. While 3I Atlas itself shows no sign of life, its existence strengthens the idea that life's ingredients are not unique to one place. For humanity, 3I Atlas arrives at a remarkable moment. A century ago, it would have passed unseen. Today, it becomes a global scientific event. Its discovery is not just about the object itself, but about our growing ability to notice the unexpected. Yet 3I Atlas ultimately resists complete understanding. It cannot be revisited or chased. It offers only a brief glimpse before disappearing into the dark. That limitation is part of its power. It reminds scientists and humanity that the universe does not slow down to be studied. As 3I Atlas fades beyond observational reach, it leaves behind a transformed perspective. The solar system is no longer a closed system, but a crossroads. Interstellar space is not empty, but active. And discovery is no longer limited to what belongs to us. In the end, 3I Atlas does not need to answer every question to be revolutionary. Its true impact lies in what it forces us to accept, that the universe is interconnected, dynamic, and endlessly surprising. Long after it vanishes into interstellar darkness, its legacy will remain, marking the moment humanity realized that visitors from other stars are not rare anomalies, but part of the natural rhythm of the galaxy itself.